Okay. Algorithm. Okay. Well, let me organize my board. Oh, sorry. Okay. So now, when we talk about algorithm, there are just some few things you need to note here. The first thing, you need to know the definition of an algorithm. So algorithm, in fact, is something we practice in everyday life. When I say practice in everyday life, let me just take a small scenario. Let us say you want to cook eggs. So I'm sure that frying eggs, in fact, let me just say fry eggs here. So frying eggs here, there are different steps you need to follow in order to have your fried eggs at the end. Just like this step generally is in your head, so it's not as if you need to write a step to fry eggs on somewhere on the paper before you follow it. No. So now, so just put in mind that, or just note this, that these steps that you are following to fry your eggs is what we call an algorithm. So an algorithm, in fact, are just the different steps, or let me just say the different instructions we follow to solve a problem. This is what we call an algorithm. Exactly that. So if I want to define algorithm, I'm going to say this. So example, let us say these are my different steps here, for example. So these steps here that I'm following to solve a problem, we call it an algo. But now, what you realize is the step of instruction that you are following is always finite, meaning that it must start somewhere and end somewhere. That's why generally when you are defining algorithm, you talk about a finite sequence of instruction. Sequence because it's not a single instruction, so you have multiple instruction. So either you say a finite sequence of step-by-step instruction, or you just say finite sequence of instruction, or finite sequence of set of instruction. So we have different way of saying that there's no problem there. So now if I'm defining algorithm, this is what I will say, because knowing the definition is very, very important. So an algorithm refers to what? So it is a finite sequence of instruction used to solve a problem. So this is an algorithm, finite sequence of instruction used to solve a problem. So after knowing this definition, the next thing that you are supposed to know here is characteristic of a good algorithm. Very important to know this, because past question they will always ask this type of thing. Now we talk about characteristics of a good algorithm. I'm just going to mention few. I'm not even writing all. I will just mention. So make sure that if you look these videos after, you copy it inside your notebook. So the first point is that a good algorithm should be finite. That is, it should have what? Start and end. So don't be writing an algorithm where you start and we are not seeing the ending part. No, a good algorithm should be finite. Either you see finite or you see definite, or you see definite. It means the same thing, please. Good. So meaning what? This F here, sorry. Meaning that a good algorithm should have what? The start and the end. So the next thing here is that a good algorithm should have at least one output. Why? Simply because when you are writing an algorithm, it's to solve a problem. So at the end, you must have an output, because you are following steps to do something. So you must see the output of what you did. So that's why here one of the criteria that it should have at least minimum one output. Doing an algorithm or following an algorithm without producing an output is as if you never followed any algorithm. So I think this point is also very clear and easy to retain. So master the first two. Now the next point here is it can take 0 or more. Let me just write big. It can take 0 or more input. So this one is also very important. Example of an algorithm that takes 0 input. Imagine that you enter into a restaurant, because generally there is something you need to retain also, because sometimes then you are not even understanding why you are studying this thing of algorithm. Today, I think everybody knows what is software. Software, generally, they say these are set of instructions that help the computer to work. Sometimes some people will say these are set of programs that help the computer to perform tasks. So all these things are the same definition. So just to tell that all this software that you are seeing to outside today, When I'm talking about software, I'm talking about both application software and system software. Application software are software that help users to perform specific tasks. Like this WhatsApp you are using, Microsoft Word, Microsoft Excel, and so on and so forth. So anything in fact concerning software, please never forget that these are programs. Meaning that people are sitting down and they are writing program. And what is a program now? This is another question you must ask yourself. A program in fact is just an algorithm written using what we call a programming language. Meaning what? That normally the aim of writing algorithm is just to automate a particular task. Like today people are having calculator. If you want to calculate maybe, I don't know, the sum of very large number, I'm sure you use your calculator. Calculator is doing magic. No, the calculator is having a program there. That program in fact is just an algorithm that has been written by someone, by a human being like you and I. And the calculator is executing it. Now the calculator in that case now is your computer. But for the calculator to execute, you cannot just write normal algorithm using your normal English language. No. There you are using what we call programming language, because the computer cannot really interpret your own language. When I'm saying your own language, it simply means what? That you are an Anglo-Saxon. That is why when you are writing your algorithm, you are using English words, things like that. But just know that those in the French section, when you are writing your algorithm, they use the French language. Those in China, they're using Chinese language, and so on and so forth. So generally, algorithms are being written based on our native language. Good. That is why to avoid any problem of computer executing all these languages, they created what we call programming languages. Meaning that language that can be understood by, but that can be interpreted by computers. Let me say it like that. Good. So the aim of writing algorithm is to change it now into programs after. Meaning that is to convert your algorithm into a program that a machine can execute. So this is exactly what happened. Now let me just take the case. Now I was just saying that to introduce what is a software. Now you can enter into a restaurant and maybe they're having a software that I don't know, you click on a button and it shows the menu of the restaurant. So you are seeing that this type of program, or let me just say this type of algorithm, is not taking any inputs. Like you are just executing and the menu displays automatically. So the menu that displays here is an output, but the user did not enter any number or anything before having that. No, he's just clicking on the button to execute and he has the output. So this is an example of an algorithm that does not take what an input. Now example of algorithm that take inputs. A simple example, let me just take something like algorithm to calculate the sum of two numbers. This is a clear example. The question here is, like your calculator is having an algorithm. Can you calculate numbers without you entering the numbers first? No, you must enter the number. This number that you are entering represents your input. And now the algorithm will take the input and process and give your result. Like if you enter input 4 and 5, maybe you are doing sum, the result will be 9. So this type of algorithm takes input. So just to explain the point, I'm just saying all this to explain this point, that an algorithm takes 0 or more input, because this is a point that generally students don't even understand. They just cram it like that. So please take note of that. Now we go to the next. So this is already 3. A good algorithm should be unambiguous. So this one is very important. So what the meaning of ambiguous? So ambiguous normally is an English word. When you say something is ambiguous, it simply means that the thing is not clear. So saying that a good algorithm should be unambiguous, we are simply saying that a good algorithm should be what? Should be clear. Take note of that, please. A good algorithm should be clear. Clear here simply means what? Like, I don't want to ask a student that, okay, give me the different steps to write X. Maybe the student take a piece of paper, write the different steps there. Then I take that piece of paper, because that piece of paper, the different steps she's writing there is the algorithm that I'm supposed to follow. And that algorithm the student is giving me, normally even 10 students or 10 person can follow the same algorithm, and we are supposed to have the same output because we are following the same algorithm. But imagine that at the end, after following the same algorithm, we are having a different output, meaning that what I'm having is not the same taste as what the other person are having, and so on and so forth. So in that case, it simply means that the algorithm was not clear and everyone was having his own interpretation. Maybe there's a particular sentence that no one is understanding, and the person just think that maybe it's this, and he's having his own interpretation, do what he think. Now I do the same thing, I do what I think for that step, and at the end this is what make our output are different, because the algorithm was not clear and people were having different interpretation. And a good algorithm should not be like that. A good algorithm should be in such a way that if you write one algorithm, even if 100,000 people are executing it, they must have the same output. And I think, I take again an example of your calculator. The algorithm to calculate the sum of two numbers. I'm sure that if I take my calculator at home, you upon 4 plus 5, I'm going to have 9. Any other person amongst you, take your calculator, you point that same 4 plus 5, you must have the same 9. So the algorithm is not ambiguous. The algorithm is unambiguous. The algorithm is clear. So instructions are clear. You always have the same input for the same set of you always have what? Correct output for different set of inputs. So this is the meaning of algorithm should be unambiguous. The last point, a good algorithm should be efficient. This point is very, very important. Important in the sense that when they say a good algorithm should be efficient, what is the meaning of efficiency? So that is, a good algorithm should take less time to execute and occupy less space in the computer memory. So when you say that a good algorithm should be efficient, we are referring to these two factors. Efficiency, in fact, of an algorithm is based on two parameters, or let me just say two factors. These parameters are time and space. So I'm insisting here because they say pass this equation where they're asking that. Like they will say, what are the parameters that determine the efficiency of an algorithm? Or they say, what are the factors that determine the efficiency of an algorithm? Please don't forget that it's time and space. So mean that when they say that a good algorithm should be efficient, it simply means that a good algorithm should take what? Less time to execute and occupy less space in the memory. Meaning what? Imagine that you have an algorithm that calculates sum of two numbers. But when you enter your two number, it takes maybe 1 minute before giving you the answer. So you have seen that it's slow. So in that case, the algorithm is not efficient. Compared maybe to another person having the same algorithm, but that takes less time to execute. And it's the same with the space, in fact, occupied by the program in your memory. Good. Something taking 5 megabytes, another taking 10 megabytes. If they are doing the same thing, it's sure that you prefer the one of 5 megabytes. So this is what you need to know concerning characteristics of a good algorithm. We have so many other characteristics. It should be I've talked about efficiency, it should be effective things, but at least these are the most important ones I've listed here. Good. Now, after knowing the characteristic of a good algorithm, you need to know now how to represent algorithm, because we are just talking about algorithm. If I just give a paper to a student that, okay, write the different steps to cook rice, I'm sure the person will just say, number 1, write, number 2, give this, number 3, and so on and so forth. Just know that now in computer science, or let me just say in ICT, we have ways of representing what algorithm. So I'm going to talk about the two important methods generally being used here. So ways of representing algorithm. So here I'm going to talk about the first one. The first one here is what we call pseudocode representation. So this is A. After that, we are going to go to B, which is flowchart representation. Good. So I'm doing so that when we are answering question now, everything should be clear, completely clear for you people. Now, what's the pseudocode? So a pseudocode is a textual representation of an algorithm. Representation of an algorithm using keywords. Good. So this is what we call pseudocode, textual representation of an algorithm. I'm seeing some students defining pseudocode by saying that a pseudocode is the representation of an algorithm using English-like word. 0. Why 0? Because I'm saying this again and again, that when you are writing an algorithm, you are using your native language. So you cannot be defining pseudocode by saying that it's a representation using English-like word, as if those doing French school, they are not also writing algorithm, or those doing German school, they are not doing algorithm. So when you are writing algorithm, there is not a specific language. No. Pseudocode is just a way of representing. And you are not representing using a particular language. No. Any language that you are understanding, you can use it in fact there. But you are in the English school, so it's clear that you use what? The English language. So it means that your keywords here will be English keywords. So I'm going to list some of them. So better another person define maybe pseudocode by saying that it is the representation of an algorithm using text. Yes, if you say like that, at least you have marks there. You have marks. So by this, the simple definition here, it's a textual representation of an algorithm using keywords. Good. Now, when they say using keyword, the next thing is you need to know some of these keywords used in pseudocode, so that when you're writing your own pseudocode, you are using them. So the keywords, in fact, are just like identifiers that help us to identify element in a pseudocode very easily. Because if you don't use keyword, people will be using their own words here. See, so we want to standardize it, in fact. So some of these keywords we have what? It is subdivided into different parts. That's what we call inputs. So for input here, generally we have get. Good. So when we talk about input, I think everybody is understanding. Input here simply refers the data you are collecting from a user. So the input is what you are collecting and sending it to your program. So, and I repeat again, collecting from the user. Collecting from the user simply means what? That when you execute your program, the user types something on the keyboard. This is what it means by data from the user. So take note of that. A second, please. Computer is hot. Good. Meaning if you're having an algorithm and that a particular data is not coming from the user, meaning that the user is not typing something, meaning that it's not an input. That is not an input, it's something else. Because some students are confused with this thing of algorithm, I don't even know why. Good. So yeah, one of the keywords we can use is get. Like I can say maybe get, I don't know, get a number A. Get a number, things like that. So we go to another keyword that we can use here. We can use input itself. The word input. So in some algorithm you see the input. So it's also a keyword. Now there's another one we call prompt. Prompt. You see prompt. Another one you see enter. Yeah. In some algorithm you see maybe enter the value this, enter this. So they are keywords. So now we go to output keywords. At the level of output keyword, you see things like display. So this one is very popular. Display. Maybe you see display this, display that. So these are output keyword. There's also and at this level, whether you are writing in small letter or capital letter, we don't care. There's no problem there. We don't care about that. Now we go to, please, what's up? Okay. So display, we are done with display. Now there's what we call print. Without F, it's not programming here. Print like this. So this is another keyword. Even output itself is a keyword. Output itself, the word output is a keyword. So take note of things like that. Now we are not done. The next type of keyword here is what we call assignment. Assignment. Meaning what? Imagine that you have something like A equals to 5. This is what we call assignment. Assignment here simply means take the value of 5 and put it inside what? Inside A. Good. In this case, what is A? Let me explain something before we continue. This is what we call variable, because this is another notion that when you are studying algorithm and you don't even know what is a variable, it's a big problem. Big problem. Good. So let me just define algorithm. So I hope people are still there. If you are there, you indicate. Hello. Hello, is it okay? Is it moving?
Yes, sir. Yes, sir, we are there.
Okay. Hope you're understanding.
Yes, sir. Yes, sir.
Okay, fine.
Yes, sir.
Okay, nice. Okay, let us continue. I want us to finish this and answer questions so that at least things like algorithm is very clear for you, because this is a chapter that this is not optional. Not optional meaning go up, go down, you see questions on that. So don't neglect things like that. Okay, I will just save the video after for those who I don't know. Some people are offline, maybe network connection, but there's no problem. I will just record. I'm recording the video now. Okay, so as I was saying, you cannot be talking about algorithm without knowing what is a variable, because you are always manipulating variables. So let me just define variable here. So a variable is a name location used to store a value that will be manipulated in an algorithm. Either you say in an algorithm or you say in a program, there's no problem. So a variable is a name location, don't forget it, used to store a value that will be manipulated in an algorithm. So e.g., I can have a name here called maybe A. If I say A equals to 5, it simply means that my variable here is called A. So the variable is just like a container like that called A. And you come and say A takes what? 5. So the aim in fact of storing things in variable is such that it should be manipulated later. Meaning what? Later on I can come and say something like maybe, I don't know, sum equals to A plus 1. So writing A plus 1 here simply means that the content of the variable A is being used here. So A is what? 5. So saying sum equals to A plus 1, you are indirectly saying what? Sum take what? 5 plus 1, which is what? 6. And sum here itself is also what? A variable. So generally any name that you see we are manipulating with this assignment operator in a program, it represents a variable. So assignment operator here simply means what? That take the value found on the right and store it to the variable on the left. So saying sum equals to A plus 1 simply means that the result of A plus 1 is being stored in a variable called what? Called sum. So this is the notion of variable here. And now in pseudocode, when I'm trying to assign a value to a variable, either you write something like this with the equals to sign. So saying A equals to 5, this is an example there. It can be anything. Good. So either we write something like A equals to 5, for example, or this A equals to 5 can be written as this. As A, you just see an arrow like this. I'm sure some of you have seen this before. So A arrow going like this and 5. So this means the same thing. Or another person can see something like this. If you see something like set A maybe to 5. So this instruction here means take the value 5 and store where? In A. So just like that, they have the same meaning. Please take note of that. Now there's another keyword that you see sometimes in some question, the keyword compute. So generally compute is for calculation. Maybe you can be having a pseudocode and you see maybe compute sum equals to A plus B. So compute sum equals to A plus B simply means that we are doing what? The operation A plus B. So generally compute is just used to indicate an addition. But this one is rare. We rarely use this one. Why? Why is that we are not using this one? Simply because when I write something like sum equals to A plus B, just the fact that you are seeing A plus B, you know already that is what? That is a calculation. So no need to precisely compute for you to know that it's a calculation. It's a calculation. But I'm just showing it because generally you'll be having question where you are the one to write your own pseudocode. Like sometimes you'll be having question where they give you a pseudocode and they ask you to translate that into a flowchart. So I'm showing you so that don't go and you see compute, you make as if you never seen that before. So that's why I mentioned it. Good. So we are done with pseudocode. Now let us go to flowchart first, so that when I will be taking an example, let us work example both pseudocode and flowchart at the same time to avoid wasting time. Now let me just move. So this is what you need to know concerning pseudocode and variable. I hope the definition of variable is clear for everybody, because in all algorithms we are always using variable, meaning that the variable helps us to store a value that will be manipulated in the algorithm, and we always need to store. In computer science, nothing is in the air. No, anything in your computer is stored somewhere before being executed. Take note of that. Good. If you have a picture, you must send. If you send a picture to your computer, that picture is going somewhere into your memory. Now by the moment you use the software to read the picture, now the picture is just moved from the memory, executed by the CPU to display it for you to see it. So everything is always stored, and it's the same principle in algorithm. Now so B here is what? Flowchart. Okay. Now what's a flowchart? So here also you have different way of defining. So as I'm usually telling my students, don't cram things. Yes, try. Who is talking? It is the diagrammatical representation. The other one was textual representation. So this time I'll just remove that textual and say diagrammatical representation of an algorithm using symbols. So here we are no more using keyword, but we're using symbol, or sometimes you say shape. Some students say shape, which is also correct. You still have your mark. So diagrammatical representation of an algorithm using what? Symbols, or you say shapes. Good. So now the next thing here is what? You just need to know the different symbol or the different shapes in fact used in pseudocode. By the time you know each of them and how they work, it's finished. Everything is okay for you. Now, so let's just mention some of the symbols here. So symbols. So the first one here is what we call the oval. So the role of the oval is just to indicate what? The start and the end of an algorithm So that's the role of oval. Good. Mean that don't go and translate pseudocode to flowchart and we are not even seeing the symbol oval. So we always need to see this symbol at the top, and the next time we need to see it where at the bottom, because it represents the start and end. Good. So now after oval here, the next symbol very important is this parallelogram. I repeat again, parallelogram. Parallelogram. I'm seeing some students when I'm making exam drawing with trapezium. I don't know. You don't know the difference between there's nothing as trapezium here. It's parallelogram. Good. Now what the use of this parallelogram is used for input or output. Good. Only. Meaning what? That when you are having a pseudocode and you are translating into a flowchart, inside your pseudocode is only when you see one of these keywords here. Let me just say it. It's only when you see one of these keywords that you can use that symbol parallelogram, because it's for input. Now, also when you see one of these keywords here for output, that you can use that symbol. So parallelogram is both for input and output. So I'm saying that because some students are funny. Someone will come and see set A maybe to something, or let me just say set something to something, and the person is using again a parallelogram to represent it. This is not an output here. This is not an input here. This instruction set is assignment, and assignment here is something else. So let us continue with the next symbol. So this is just something I wanted to precise. The next symbol here is what we call rectangle. The rectangle. So the rectangle is used for, let me just simplify it, for processing, or you say calculate, for processing or calculation. Now, example of a process here. If I take something like A equals to B, this is a process. A equals to 5, this is a process. Why? Because this process means what? That computer, the computer that is executing, in fact, your instruction. I'm just saying computer here, but in reality, everybody knows who is executing it, because each instruction that you are writing into the computer, the CPU is the one executing. The CPU, the brain of your computer. So when I'm saying the computer executing, I'm indirectly saying that the CPU executing it, even though it's not all, because generally you translate it into a program and there are so many things that happen, but I'm just really explaining using simple words. So meaning what? That the computer, when the computer is executing it, the computer will say this instruction, and this instruction simply means take 5, put here. So you are seeing that this 5 is not the user that press it from the keyboard. No, it's already there in the instruction, and the role of the computer is just to take it and put it where? Inside A. So this is a process. So by the time the computer is doing a process, please, the symbol used is rectangle. Now for calculation, I don't want to explain calculation. Calculation, by the time you have any arithmetic operation, whether it's addition, subtraction, multiplication, division, in fact any of these things, automatically use what? Rectangle. Take note of that, please. Next symbol is what you call arrow. So the role of the arrow here is just to connect flowchart symbols. So when you are using this symbol, generally they are not just idle like that. No, you need to connect them, and we are connecting them using this arrow. So that's the role of arrow. Now the next symbol is what we call diamond. Diamond, or sometimes we call it what? Rhombus. Sorry, a rhombus like that. So the aim of this symbol is for conjugating conditions. Don't forget it. Now under condition, now you are going to see the next part that we are supposed to study is what we call control structures. It's under control structure that you see the different type of condition that exist. But the popular one that you know very well is the if statement. Meaning that when you say if this, do that, else do that. So by the time you're already having this type of thing, you are using this symbol, but we are coming to that. It's not all, because it also loops. Now, the last symbol I want to show you is what we call a connector. The connector is just a circle like that. And the whole of the connector is just to join two flow lines. Meaning what? Let us say I'm having a flow line here, I'm having a flow line here. if you want to produce a single flow line. Just don't come and do this. No, this is not correct. So you take the first flow line, you use your connector, you take the second flow line, and from here you produce a single flow line. So this is the use of the connector. Nice. So we have studied all the different symbols. Now let us take an example to consolidate all what we have studied now. So example, let me just give this example. Algorithm that calculate the sum of two numbers and displays the result. Good. So this is an exercise here that they ask you to write an algorithm that calculates the sum of two numbers and display the result. So let us do this algorithm both in flowchart representation and both in pseudocode representation. So let me just start with the pseudocode representation. Now, pseudocode representation, the first instruction here is what? Start. Good. Next instruction. Before we even continue, each time you have this type of question, because as I was telling you have different ways of asking question. Let me repeat myself again. Either they give you a description like this text and they ask you to write the algorithm based on this text. This is the first way they can ask question. The second way they can ask question is they give you a pseudocode and they just ask you to translate that into a flowchart. Second method. Third method, they can give but now flowchart and they ask you to convert flowchart to what? Pseudocode. So please, meaning entering in the exam hall being prepared, it means you know all these cases. So don't go there and you are surprised, whereas you know very well what is waiting you in the exam. Exam means prepare before writing, and when you prepare, don't choose on what you prepare. No, if the teacher is saying that prepare here and here, it's not for nothing, because at the end of the exam, you'll be the one telling us what happened there. Good. Now, so let us solve this question. First case, they say that you should write an algorithm that calculates the sum of two numbers and display the result. So please, each time you are writing a program, the three main parts you are supposed to think of: the input, the processing, and the display. Let me just say it like that. So when you're having a problem situation, ask yourself this first question: am I taking an input? If you have to take an input, you will know what to do. The next thing is, if I'm taking input, what am I doing on this input? This is the next thing. That is at the level of processing. Because anything you are doing on input is already processing that you are doing there. So it can be a calculation or anything, affectation, I don't know. Now, the last step is always display. Always and always, because there is no algorithm you write without displaying an output. You must always display. Now, yeah, this problem you're raising. The algorithm calculates the sum of two numbers. But you ask yourself, can you calculate sum without even having the numbers? No. So you are seeing that just from this sentence, you realize that, hey, I need inputs. And the inputs here are the number I need to sum. So how to obtain the input? You use the instruction word. We have different instructions for different keywords for input. So let me just use get. I like to, because these keywords here, it's not say we must use all of them. No, choose what you like. If you think that you like to use enter for input, use enter. I generally, when I'm writing my pseudocode, I like to use but get. So use what you like. I'm showing all because when they give a pseudocode in the exam, they can use any of them. So you are supposed to understand it. Good. So yeah, I'm going to say get two numbers A and B. Now there's something. Some students are asking themselves that, sir, you are getting two numbers. Is A, B a number? Why are you saying A and B? Why are you not saying get two number 1 and 2? So there's something they are forgetting here. A and B here represent what we call my variables. So these are variables, meaning what? When I say get two number A and B, it means that I'm having a variable here called A and a variable called B. So that if the user enter the first number 5, that first number is stored in a variable called what? A. If he enter a second number called B, that value is stored where? In a variable called, what am I saying? If he enter a second variable called, let me just say 6, that second variable is stored in the variable called what? B. And why are we using variables? Simply because a program is not meant for one person to use it. No. Like your calculator, you take your calculator now, you can do 5 plus 6. After that, you click on the reset button and do something like 10 plus 11. So you're seeing that you're already doing another calculation. Imagine that you were not using variable. How are you going to store different values like that? So you need variable, you need container, so that when you're done with a particular calculation, reset is just doing what? Cleaning what you're having inside your variable, so that another person can now put in other variable and still use it in the program. That is why variable are very, very important. So it's really paining me when I'm seeing a student writing something like get two number, you have just 1 and 2 there, as if the only calculation is 1 and 2. It's tomorrow someone wants to sum 3 and 4. It's your program, meaning your program is static, your program is not making sense. So please, I hope I've cleared the doubt of some students here about this thing. Good. Now here, variable, remember their names, location. So here I'm calling my location A, the first location A and the second B. So here you can decide to call it maybe num1, like that. Let me just even change the A and B. Let me just write something else, so that you see that this thing that is flexible. It's not as if, like here, I can just say enter two number, num1 and num2. In this case, my variable, I'm calling them num1 and num2. Okay, so now you continue thinking, okay, I'm already having the two numbers, so what am I doing next? It's clear. If you have the two numbers, you just start the sum directly. So here you need another variable. That variable, it depends on you. I can call that variable sum, and I will say sum is taking what? The result of num1 plus num2 plus num2. Good. If you want, you call that variable result. Just know that the name that you are putting is just a variable that will store your result. It's nothing else. Now we have calculated. The question said what? That algorithm that calculates sum of two numbers and display the result. And what's your result here? Your result is sum, because sum is storing what num1 and num1 contain. E.g., imagine that here num1 the user enters something like 4, num2 the user enters something like 3. So 4 plus 3 is what? Is 7. And here we are saying that sum is equal to num1 plus num2. So you are seeing that this 7 will be stored where into sum, meaning that in your memory you'll be having a location called sum and having a variable 7. So that's why here to display the result you will say display sum, meaning what? You are displaying the content of sum, because sometimes also seeing students doing funny mistake, like a student will come and say sum equals to num1 plus num2, and here he's going to say but display result. How can you say display result? Result is a variable that exists. No, if you want to say display result, don't write sum here, write the result equals to num1 plus num2. And that's why sometimes people are making that mistake, because you don't even have the notion of variable in mind. So after this, what next? Is all. This all what the algorithm is doing. So when you are done with the algorithm, you write what? End, or you write what? Stop. So this is how you write pseudocode. And for ICT, there's nothing. ICT, there are simple questions like this, like what I did here. I think this one year like that. I don't even remember June. If I will check the year. If I see it, I will bring it back here so that we can solve it together. Where you have a small question. I think there is a question where they are asking you to collect the price of an item from a user and the number of quantity for that item. Then you calculate the total price by doing what? Unit price times total, then you display results. So you are seeing that it's the same principle. Collecting, you use your instruction, you use the variable to store what you are collecting. You use another variable to store the final result of your operation, whether you are doing addition, multiplication, I don't know. Then you display what you have in your you display what you have inside your variable that stores the result. Okay, so now we are done with pseudocode representation. So let us go now to flowchart representation of this same algorithm. Flowchart. Now for the flowchart, let me just do a simple translation. So there's no problem. First instruction here, you see start, and you know that start is what? Oval. So you draw your oval for start. You draw a line. The next thing is what? Get two number, num1 and num2. Get is something, meaning we are taking an input from user, meaning the user must enter numbers. So, and we know that to do so we use which symbol? Parallelogram. So here you say get two numbers, num1 and num2. You go to the next. This is sum equals to. So by the time you see equals or you see plus, don't even think twice. It's a process. You just draw your rectangle directly. Don't even think. because sometimes students are wasting time thinking, I don't know, whereas there are certain things that when you see already, you know what to do. So you just come and write sum equals what? A plus B. Not A plus B, please. No 1. Yeah, we said no 1 plus no 2. So this is another mistake that if you do in the exam, the examiner will just say you don't know what to do, or maybe you are looking for the work of someone else. Now the next instruction is what? Display sum. And we know that display is output, and output is what? Parallelogram. So parallelogram is input, output. So after that you have what? N. So N is what? You still use your oval symbol, and it's all. So just know that what we are just from doing now is, let me just say, 45% of what you need to know concerning algorithm, 50% even, because there's another thing we need to see again together, so that you're at least 100% completely, meaning that after doing that, I'm not saying which question should be more than you with these explanations. So I'm still here. Before we continue, it's the last part that we can cover maybe in 20 minutes. So if you can support, we just finish it. So, but at this level, is it okay? Those who are present, is it okay?
Yes, sir. Yes, sir.
Okay, I hope it's clear. If you have question, you ask any doubt, because sometimes you doubt on certain things. If everything is clear, then fine.
So for me, it's okay.
Nice. Okay, so let us proceed with the last part and solve past questions. Everybody knows the name, right? School for, you just type school for all GCE. Good. Now, when you're at the level of the YouTube channel, generally to look videos there, so you click on the logo first, you fall on this page. So if you want to see videos without checking, you see, you go to playlist, you see playlist here. When you click on playlist, you see now different playlists. So playlists are just like folders grouping videos.